Welcome back to Hierarchy of Quadrilaterals. Let's review what we've learned so far. So we started at the top of our hierarchy with our quadrilateral. Again, a quadrilateral is a four-sided polygon, 1, 2, 3, 4 sides, and the interior angles must be 360 degrees. Expanding along that idea of quadrilateral, we can get a more specific one, the trapezoid. Now, a trapezoid in general just has one pair of parallel sides, so again, we labeled that. A more specific trapezoid is the isosceles trapezoid. In this trapezoid, we're looking at that idea of isosceles. So our two legs are congruent. Our common base angles here and here are congruent. The diagonals going across the shape are congruent. The adjacent angles that are not along the same base, so angle C, angle D, angle B, angle A, are supplementary. They add up to 180 degrees. And the mid-segment of the trapezoid is equal to 1/2 the bases. So we add the top, the bottom, divide by 2, and we get that length. Today we're going to look at a more specific type of trapezoid, the parallelogram. So a parallelogram not only has one pair of parallel sides, but actually two pairs of parallel sides. So we will label that our first property, two pairs that are opposite of parallel sides. More specifically than them just being parallel, but the opposite sides are congruent. So we have this side being congruent to this side, and this side being congruent to this side. So those opposite sides are congruent. Third property, not only are the opposite sides congruent, but our opposite angles are congruent. So we have those two angles being congruent, and we have these two angles being congruent. So our opposite angles are congruent. Now, because those are congruent, right? Those are congruent, these are congruent, they all add up to 360. That means that the adjacent angles are supplementary, meaning they add up to 180 degrees. And again, looking at that idea of our parallel lines, if we continue out with those parallel lines, these two angles are again same side interior angles, so they will add up to 180. The special thing about parallelograms is it is any adjacent angle, not just these two, but along any angle. So those two, those two, those two, these two, all of them are supplementary. So all adjacent angles are supplementary. Fifth property has to do with those diagonals again. So when we draw in our diagonals, going across, again, those diagonals go across, but more specifically, they bisect each other. So diagonals bisect each other. What does the word bisect mean? Well, remember, bisect was to split in half. We talked about perpendicular bisectors, right? Bisecting, we're splitting it in half. So if it's bisecting each other, that means that this half of the diagonal is congruent with this half of the diagonal. So we'll label that with 3 dashes. And likewise, this diagonal, we'll label this one with a little squiggly, is congruent with this half. It splits it right in the middle. So again, reviewing our parallelograms, we have two pairs of opposite sides that are both parallel and congruent. So the opposite sides are congruent and parallel. Opposite angles are congruent. All adjacent angles are supplementary. Those two, those two, those two, those two. And the diagonals bisect each other. So when where they meet, right in the middle, is the halfway point. From here to here, those two are congruent. And from here to here, and here to here, those are congruent. And I have a quick joke about parallelograms. What did one angle in a parallelogram say to its adjacent angle? Sup. Get it? Because they're supplementary. So this one's saying sup, sup, sup. Alright, bad joke. But we will continue with our hierarchy next time.